All right, hello once again. This is Jeff Scott of Rankin Technical College. And because half of our class, as you know, is now out with either COVID symptoms or a family member with COVID symptoms, I've decided that the last few chapters in the book, I am going to tape them and I will put them out on the system. Now, chapter 13, which we really won't spend a lot of time on, as you can see, is broken down into three different areas: permissions, performance, and security best practices. Now let's just hit on each one of them. All right. For permissions, the idea is most everything goes through the Android manifest file. So you've got to ask for permissions. We've done a little bit of this already as far as just asking for permission to use the internet. All right. And we'll look at it in a little bit more depth and breadth of coverage. This isn't a particularly long chapter. All right. Then we'll go into performance, how to make your app run faster, better, more optimized, etc. And then finally, security best practices. And that's one thing we really haven't delved into at all in this class. But much of the stuff that's in here should make sense to you as far as you want to make sure that if you create an app and you put it out there that it's as secure as possible. You want to make sure that everything you do always is as secure as possible. So as the author mentions, you've now learned the fundamental skills needed to build Android apps. This lesson discusses best practices for permissions, performance, and security. All right. So as it says, in the past, there were times when we needed to do something. Our biggest one was to be able to connect to the internet. All right. So notice here it says, ask permission if it isn't yours. An app is free to use resources or data that it creates, but it must get permission to use anything and everything, basically, that does not belong to it. Even something as simple as being able to use the user's camera, you need to ask permission. All right. It says you might even wonder why you need permission to use the camera, and it's because the camera hardware does not belong to the app. Belongs to basically to the system, and as it says, your app must always get permission to use anything not part of the app itself. So we have done this before where we've come into the manifest file and we've done the uses permission statement. Now the key thing is the one we've looked at, like I said, has been the internet, but notice the Android framework provides more than 100 predefined permissions. All right, and here's some examples. I'm not going to read these to you. All right. Some of them, as it says, are obvious. Some are not obvious, such as being able to collect battery statistics. All right. Again, connecting to the internet, which we've already talked about. To use hardware. All right. Android includes predefined permissions for initiating a phone call without requiring the user to confirm it, reading a call log, capturing video output, anything that could potentially contain pertinent, important, and possibly even personal information. It says you can see all the system-defined permissions. Let's see if we do this, if we bring this up. So this is manifest permission, and it's just an alphabetized list. All right, I'm not going to go through it, but as it says, there are well over 100 things that are in there. All right. So Android classifies permissions in one of two manners, either as normal, as it says here, for actions that do not affect user privacy or user data, and dangerous, things that can potentially affect user privacy or user data. All right. Android automatically grants normal permissions, but asks the user to explicitly grant dangerous permissions. So in other words, if there's anything that could compromise the system, you must ask for permission to do it. All right. Apps must list all permissions they used in the manifest, even the normal permissions. And again, that's why we had to go in and put in when we requested internet permission. The ways users grant and revoke permissions depends on the version of Android they're using and the version of the app this was created for. So as it says, pre-Marshmallow or pre-Android 6.0, or as it says if you're running on a device that's using that, Google Play asks the user to grant required dangerous permissions before even installing the app. And they show you this. So you must click the accept button. If the user changes their mind and wants to deny permission after the app is installed, as it says, the only thing they can do then is uninstall the app. Okay? From Marshmallow or Android 6 point up, as it says, and in the devices also Marshmallow and up, Google Play does not ask the user to grant dangerous permissions before installing the app. Rather, when you start to do something that requires that level of permission, it shows a dialog box. All right? As it says, well, and it's kind of a silly example, but you get the idea. So as mentioned, the user can grant or revoke individual permissions at any time. You do this by going to the Settings app, choosing Apps, and selecting the relevant app, and then setting the permissions accordingly. So you'd come in there and notice it's a bunch of these switches, so things you can turn on and you can turn off. As it says in the old permission model, Google Play and the Android framework worked together to get permissions from the user. So there wasn't much the developer had to do other than just, make sure that the app was listed in the permissions if they needed the Android manifest file. But in the new one, you can't assume that if the app is running, the user was granted the permissions. As it says, the user could grant the permission the first time they run the app, but then change their mind later. So the app must check whether it still has permission every time in the new way that this is done. The SDK, as mentioned there, includes application program interfaces for checking if the permission has been granted. They show an example there. Now notice, because this is a chapter of best practices. So the books here says, we recommend that you use the user support library methods for handling permissions. Now, I don't believe, since the two of you are doing games, and I know that Keegan, at least you are simulating making bets, but you're not really making bets. All right, so I don't think that this is going to be real pertinent to either one of you. All right. Notice this lesson does not go into detail for how to use APIs for handling permissions, but they do provide a link. I'm not going to click it. All right. So the best practices, notice, I don't disagree at all with the first statement. It says when the app asks for too many permissions, users get suspicious. It's not just that. If you make it too hard for someone to use your app, especially if it's a free one, they're just going to say it isn't worth it. Maybe it's especially if it's a paid one. I don't know. So whenever possible, as it says, use an intent instead of asking permission to do it yourself. For example, as it says, if your app needs to use the camera, set an intent to the camera app. And that way the camera app will do all the work for you. Your app then does not need to get involved in permissions. So if you want more, notice predefined permissions, best practices, and some of those we just looked at, and a blog entry about runtime. I'd suggest if that becomes an issue to you, I'd start with the blog entry, then go to the best permissions, and then go to the predefined. All right. So next, performance. As mentioned, you've done everything to make your app aesthetically appealing. And it says to make it stand out in the crowd, you should make it as small, fast, and efficient as possible. Well, think about how you can do that. First of all, you may run into trouble if you're constantly going, and let's say either you're going out to other apps to do something, or you've got tons of really big picture, images, etc. There are ways that that you can really add time that it takes to run the app. All right. So it says you want to consider the impact that your app might have on the device's battery, memory, and disk space. Most of all, be considerate of users' data plans. So again, they're only going to start giving some recommendations here. This is not an all-inclusive list. As they mention here, maximizing performance is all about balance, finding and making the best trade-offs between app complexity, functionality, and visuals. So you want to work with the user to make their experience as good as possible. All right. So how can you do that? Number one, keep long-running tasks off the main thread. So this course has already talked about moving work off the main work thread. Okay, and we've talked a little bit about that in here. And there's ways that you can check that. So it says you can check how well your app does at rendering screens within the 16 millisecond limit that Android imposes by using the Profile GPU rendering tool on your Android device rather. As it says, go to Settings Developer, scroll down to Monitoring. All right, select Profile GPU rendering and choose on-screen as bars so you can start taking a look in there. All right. So there you go. One bar, as it says, represents one screen rendered. If the bar goes above the green line, it took more than 16 milliseconds. And you can see in this case, it did for virtually every page. All right, so the colors of the bars represent the different stages in rendering the screen. And realize that you have only a certain amount of control in here. Yes, you can come in and you can try to do what you can to make this as simplified and work as well as possible. But once you go and you put it out there and someone downloads it, you really don't have any control. I mean, especially if they got an older phone, etc., and they're running a lot of other apps at the same time, you don't have all that much control over, how fast you can make something work on someone else's machine. All right. It says if you want to read more and you want to interpret the results, it says you can go out here to Analyzing with Profile GPU rendering. It will help you identify the parts of the UI interaction that are slower than really they should be. It says if the green input section bar is large, then the app spends a lot of time handling inputs. To fix this, consider when and how you request user input and if there's ways to more efficiently, set it up. But this course, as it said, has talked about how to make your apps interesting and visually compelling using things like material design. It's taught you how to use the layout editor. You've learned a lot of different things. It says your layouts will draw faster and use less power and battery if you spend time designing them efficiently. So what you don't want to do, and that's one of the things I have not done in here, is have deeply nested layouts. In other words, it is totally possible, plausible, inside of Android to go and have layouts within layouts. I haven't gotten any further than maybe having a linear layout inside of my constraint layout. But the more layouts you have, and it says, as it says there, especially if they're narrow and deep, meaning there's a lot of them without too much in each one, the Android system has to perform more passes to set everything up. It says consider how you can combine, flatten, or even eliminate views. Also, as it says, they're overlapping views, which result in overdraw, where the app wastes time drawing the same pixelated image or whatever multiple times, and only the final rendition is visible to the user. Again, you want to look at that and see how you can simplify it. So as far as that goes, as it says, for simplifying layouts, as you can read here, make sure the layouts include only the views and the functionality actually needed in the app. Don't try to design something that's cool at the expense of having it take longer. Simple layouts, as mentioned there, are generally more visually appealing. They draw faster, and that's going to be what the user expects. Flattening your layouts means reducing the number of nested levels. All right, as it says, if your layout contains a linear layout inside of a linear layout inside of a linear layout, maybe you don't want to do that. Maybe you want to have just a single constraint layout. One of the reasons that I believe, whether I'm right or wrong, that we've gone to constraint layout as the default is it can minimize some of these problems they're talking about. All right. Finally, minimizing overlapping views. It says imagine that you are painting the door of your house red. Then you paint it again green. Then you paint it again blue. As it says, in the end, the only color you see is blue, and you wasted your time painting it multiple times. Well, each time you bring something up on the screen, if the idea is you're bringing it up and rendering it so you can re-render it very quickly again, you're wasting computer power. You're making it harder on the system and on the user than it has to be. So as it says, there is a guide there for reducing overdraw that you can take a look at. All right, finally, monitoring the performance of your running app. As it says here, Android Studio has tools to measure your app's memory usage, to measure its GPU, CPU, and network performance. App crashes typically are related to memory leaks, where your app allocates memory but does not release the memory. Okay? If your app uses more memory than it should, it'll eventually use up all the memory on the device. So as mentioned there, you can use the memory monitor tool that comes with Android Studio to see how it's going. How do you do that? As it says at the bottom of the window, click the Android Monitor tab. By default, it opens up Logcat. Well, if we come down here, and I'm going to show you what I worked on this weekend in just a bit. But you should know by now, we've gone in here, all right, and we've worked on Logcat, we've worked on Profiler, but you can look in here and you can look at not only the database inspector, but you can look at the Profiler where you can get some of this stuff in here done. All right. It says click the Monitors tab next to Logcat. Now, I'm not going to lie to you, I have not looked at this previously and I didn't see it in there. So this is Logcat. These are all Logcat things as far as I know. So if it's in here, I've got event log and layout inspector. I'm not sure exactly where it is. All right. They show, though, if you do run it, the kind of thing it'll look like. And again, the idea is it's trying to show if there's anything that's a hog. So these are the monitors that they mention here. The memory monitor reports how the app allocates memory. The CPU monitor lets you monitor the central processing unit. The GPU monitor, which allows you to, as it says, it shows you how long the graphical processing unit is taking to render things on the screen, and the network monitor to show when you're making network requests. All right, so the last thing that's discussed then in the chapter are security best practices. And again, most, all of this will probably just be common sense. But it's amazing. Sometimes people in either their rush to get something put out to a system or for whatever reason, do things they don't have to, probably shouldn't do. So as it says, much of the burden for building secure apps is handled by the Android framework. For example, apps are isolated from each other so they can't access each other or use each other's data without permission. However, as an app developer, it's your responsibility to make sure your app treats user data safely and with integrity. You're also responsible for keeping your own data safe. All right. So as mentioned, the lesson here has already discussed how Android uses permissions. But even if the user gives your app permission, it says don't do it unless you absolutely need to. You don't want to do anything that's going to affect their data in a negative way. I mean, think about the ramifications, because if you do that, sooner or later somebody is going to put out a review of your app, and if that's what they put down, that very well could keep other people from wanting to download it. All right, so as it says here, just because the user gives your app permission to update their calendar doesn't mean you have permissions to delete calendar entries. All right, so Android apps operate on a foundation of implied trust, meaning users trust that their apps will use data in the way that it's supposed to be used. Your app must only read and write data when it's absolutely necessary and only in a way the user would expect it to do. Once your app has read any private data, you must keep it safe, prevent any data leakage, prevent it from being looked at from other apps where other people could conceivably get a look at it. All right. Depending on how your app uses user data, it says you might also need to provide a written statement, some kind of a privacy policy. All right, so at least you're letting the user know that if they ask for something, and you might put a link in on your activity that says, please click here to read the privacy policy, where you either bring up another activity, or you link to something, maybe you even put a web view in there where you can actually, basically drop in almost a browser into your app to have them look at the privacy policy. Be aware of the fact that the user acquires, downloads, and buys in your app. Everything they buy is theirs. So your app must store it in a way that the user has access to it, even if they uninstall the app. All right. Logs are a shared resource, so be real careful. Don't ever write, any private data to logs. All right. As it says there, with Wi-Fi, design your app to protect user data if they're connected to Wi-Fi. That's a big area. People go into to a public Wi-Fi spot, and other people go in and try to basically, take whatever data that they're sending, receiving, etc., anything that they can look at, and take a look at it. For transmitting sensitive data, implement authenticated, encrypted socket level communications. We haven't gotten into anything like that in here. All right, validating user input. We've looked at this. If your app accepts user input, you need to do it. You need to make sure that it does so, does not bring anything harmful with it. Common problems are buffer overflows. Typically, a buffer is an area in memory where it'll hold things, and if you put too much in it, it's like the old proverbial trying to stuff 10 pounds worth into a 5-pound bag. Good way to make your program blow up. Dangling pointers. Well, unlike other languages like C, where you work a lot with pointers, you do work with pointers in Java, but it works behind the scenes. And it's typically not something you're going to have a lot of control over. But if you do set your app up wrong, it's another way to bring programs down. Off by one errors we've talked about quite often. That's when you're working with arrays and other collections and you're trying to loop through them. So rather than saying start at 0 and go to 1 less than the count, you start at 0 but you go to the count. So you're going 1 more than you should. As it says, Android provides a number of technologies that reduce these errors, but they don't solve the underlying problem. You can prevent these vulnerabilities by carefully handling pointers and managing buffers, and I'd also say by doing more than your share of testing. It's the old programmer joke, test, and step 3, go back to step 1. All right. If your app allows users to enter queries that go to an SQL database, you must guard against SQL injection, where malicious users can inject SQL commands into a statement, and not just SQL commands, but anything into a statement. Quite often where stuff like this is done is if you've got a form, for example, that you want a user to fill out, and if you have not sanitized the input for the form, the user may be able to go into that form and put in, for example, malicious JavaScript and go in there and do things like remove tables, modify tables, look at potentially sensitive information, etc. It says another thing you can do to limit this is to grant either read-only or write-only permission for content providers, and that can be a real key one as well. Now, earlier I mentioned web views, and as you can see, this is the end of the chapter. All right, it says one of the view classes in Android is web views. When you drop it in, it looks almost like it's an image view. But unlike an image view, which of course is designed to bring up an image, a web view is designed to bring up a web page. As it says, this course has not discussed web views, but you might have found it and tried it for yourself. We mention it here because even though it's very cool to display a web page in your app, web view comes with its own inherent security concerns. As mentioned, because it consumes web content that can include HTML and JavaScript, you must watch out again for any kind of injection that can take place, whether it's SQL injection and the stuff, I guess what I mentioned earlier, that's literally being able to get into the SQL that's been provided in the app and modifying that, or what I mentioned before, which is basically more cross-site scripting. All right. By default, the web view provides no browser-like widgets. It does not enable JavaScript, and it ignores web page errors. If your only goal is to display some HTML, this is acceptable. But if you want a fully functional web browser, it says invoke the browser application with a URL intent rather than showing the page in a web view. This is also more secure than extending the web view class and then enabling JavaScript yourself. So as mentioned, security, you can have a whole book on security. And as you can see down here, they even have more security tips, more on input validation, all right, and more on security tips if you're going to be using content providers. Now I'm going to stop right here, and I am going to go into Firebase, all right, and talk about that as well. This has been about 25 minutes or so, and I probably don't do these due justice, but at least for lack of better words, I am going through them, okay? So I'm going to go over 14, and I'm going to finish that up today. And then in class, this is more for your benefit, Angie, I am going to mention, I'm going to, and I would, what I'll probably do is I will send you an invite. But when you look in here, this is what I created over the weekend. It's by no means fantastic. It's okay, for lack of better words. It's a to-do list. It has full CRUD functionality. I did end up taking out the whether or not it was urgent. So when you look in here, so I can come in and I can add a new to-do list. So I come in here and I'll say, write, what do I want to do? I want to write Firebase app. Okay, and I click add, and you can see immediately it's put right here. I can edit it, and if I say I want to write it today, so write Firebase app Monday, 5/3/2021, and I click save, and you can see it's now been put in here. If I've done it and don't want to do it anymore, so I've shown you the insert, which is create. This is the read right here. I've shown you the update, and for CRUD, you can just take it and drag off to the right, and it's gone. All right, I'm going to very quickly just come in here and put another to-do in here, and I'm going to put in, I don't know, I'm making something up right now. Watch St. Louis Blues game. Okay, so I'm going to put that in there. Click add. You can see that it's been added. All right, why am I showing you this? Well, I'm going to bring this down here. I'm going to come up and I'm going to click on tools, and I'm going to go under tools. I'm going to go down to, where is it? No, it's not tools. Or is it tools? It is still running. Well, I'll tell you what, I'll show you it from here, because I earlier copied the database out here. So I'm going to open up this DB browser using SQLite, and I'm going to say open database, and it is on my desktop. For some reason it's not recognizing it. I guess I didn't put a .db in when I saved it. So I'll say all files. There's my to-dos database. I click open. You can see there's my schema. If I click browse data, there's the buy groceries and mow the lawn. So the one I'm not shown has been the one that I just put in, watch the Blues game, but there's buy groceries and there's mow the lawn. All right, so I wanted to show you that. I will take some time in class today to go over this and go over what I did. Okay, so I'll talk to you about that later.